Sweco is a big Swedish consultancy, but we have a big presence in the Netherlands as well. And you're right, the Nordics and the Netherlands come together in Sweco because it's one big company with one big strategy. So I want to talk today about agile electric vehicle optimization, but let me start with the real problem. The problem is the livability in the cities. Wherever you go in the world, there is a huge amount of vehicles that are just standing still. And actually we noticed it this morning in Barcelona as well, huge congestion. And it's a global problem. Cities like Delhi face significant smog, so we need to do something about it. Luckily things are happening. So for example, City of Amsterdam is planning to ban all petrol and diesel cars as of 2030 within the inner city ring roads. The UK and Norway want to ban diesel and petrol cars in 2025 or 2030. And okay, Trump has a different view, but that's okay. The rest of the world is moving ahead. Together with the Eindhoven University, we executed a study around electric vehicles because we wanted to know how is the energy demand while driving through an urban network. And actually one of the very interesting things we found out is the significant difference in energy consumption based on the temperature outside. So actually this left side is actually much better for the energy consumption than the right side. Here we have some statistics. Here we have some statistics. On the left side you see the energy consumption during summer conditions. On the left side you see free flow, and next to that when you have to come to a standstill in front of a traffic signal. And on the right side, exactly same situation, but the difference is this is winter, 0 degrees Celsius, and you can see significantly more energy consumption due to the winter conditions. And why this is because of the heater. We have the heater on, and in a petrol and diesel car, this just comes out of the petrol engine. But for an electrical car, it needs to be generated, costing a lot of energy. That's why we came up with a very simple idea. What if we link the temperature we know about electric vehicles, and we can actually optimize electric vehicles when it's colder outside? We call this electric vehicle optimization, and we add this to our smart traffic product, which is a product to control traffic signals based on loop detectors and floating car data. And in this floating car data, we actually know when an electric vehicle is approaching the traffic signal. So how does this work? Let's say this is a situation, very simple traffic light, direction left, right, and straight on. It's 22 degrees outside. And this is the time to green. Because we have a predictive model, we calculate that in advance. What if this vehicle going straight is actually an electric vehicle, like this green one? When it's 22 degrees Celsius outside, there's no priority needed, because the energy consumption is rather low. But in case it's -5 degrees, the energy consumption is much higher. And in that case, we can actually change the prioritization of that vehicle, so it actually gets green light much faster. Obviously, this is not needed when we have 50% or 100% of electric vehicles on the road. But for the time in between, this is actually a very good way for cities to promote electric vehicle use. And that's my call to action. If you're a city and you're interested to know how can I prioritize electric vehicles in my city, please get in touch and we can chat how we can implement this in your city.
Thank you very much for the presentation. I know that also the city of Hilversum is here, so maybe you can have a chat with them also with a presentation in this area. Thank you very much, Sweco.